Assalamualaikum and hi everyone. In this video, I would like to share about rotate instruction that we're going to use the rotate instruction in our step 7 software, SIMATIC STEP7, which we always connect with S7-300 CPU. So for step 7 software, SIMATIC STEP7 software, we have rotate instruction. So for rotate instruction, there are two instructions, which is ROR underscore DW and ROL underscore DW. The ROR underscore DW is basically rotate right, rotate to right. So all the data within any double word register will be rotate to from left to right. And rotate instruction, rotate left for this one, this is basically rotate left double word. And the rotate left double word will rotate all the data from right to left. Okay, and the data type is double word. So before we go further to the demonstration and example, we have to look at and revisit the data type in SIMATIC STEP7 software. Okay, the data type for this particular instruction, we're going to use double word, of course double word, whereby if we say word is 16-bit size of data, double word is 32 bits. So 16-bit, something like we have 16 boxes, which we can allocate all the boxes in all data in these boxes. Whereby the 32 bits, which is the double word, we have 32 small boxes, which we can store any size of information in these boxes. So in terms of information that we can store in this particular box is what we need to bear in mind is basically the arrangement of the data. So let me rearrange the data. So the bit arrangement will be from bit 0, 1, 2, 3, 4, 5, 6, 7, then come back to 0, 1, 2, 3, 4, 5, 6, 7. But we have to make sure that if we have the starting address, for example, the starting word address, the starting word address is word address 0. So the starting address should be here. So this is word address 0, and this one is word address 1. Okay, same goes for the double word. So we should have the starting address, which is started from the left hand side. So if we say that the address started from word address 0, so this one is word address 0, this one is word address 1, this one is word address 2, and this one is word address 3, whereby the bit address will be starting from 0 to 7, word address 1 from 0 to 7, word address 2 from 0 to 7, and word address 3 from 0 to 7. So this is the arrangement of the data. So next we're going to have a look at the movement of the data. If we say rotate from, if we say, for example, we're using rotate right, for example. So the data will rotate from left to right. Okay, from left to right. If we say the data is rotate left, the data will rotate from from right to left. We proceed with the demonstration. So here I have the SIMATIC STEP7 software on the left hand side and the factory I/O on the right hand side. And on the factory I/O, I arrange the lamp indicators to represent the bit position and the bit address of word address. Okay, so if we look a bit detailed here, so we have 16 indicators, whereby these indicators is the output word address 0, bit number 7, output word address 0, bit number 6, 5, 4, 3, 2, 1, 0. So from the yellow indicators up to the blue indicators at this particular area is for output word address 0, and for this particular group of lamp indicators is for output address 1. And I also put the push button, 2 push buttons here, whereby we're going to use the yellow push button. This yellow push button is basically correspond to the load push button, which is this one is I0.1. So when we press this push button, the value will be moved to output word address 0. So this one is hexadecimal number 8000, means this indicator will turn on, the rest will turn off. And we're going to use rotate right instruction, whereby we're going to move the status of on indicators from left to right. So I also use the M0.5, the bit 5 is already preset for one clock cycle on and off. Okay, so I proceed with the demonstration for rotate right. So when I press load push button, okay, let me disable this one first. Let me disable the clock first. So I make it, maybe I have to just delete it. So I just delete that one, or maybe I change it to maybe M0.7. Okay, just for the sake of demonstration. And when I press load push button, if you can see this one, output word address 0, bit number 7 is turned on, and it will move from left to right based on enable input, and the move is basically 1 bit position. Okay, and is basically correspond to the 1 bit position, the rotate 1 bit position. So I change back to M10.5, press download. It will download to the PLC. Okay, so if you can see here, I press load push button, you can see it move this on status of this word address 0, word address 0, output word address 0, bit number 7 from left to right, very quick. Okay, fairly quick. Okay, you can see that one. Okay, now I'm going to change the rotate right instruction to rotate left instruction. Okay, rotate left instruction. So I'm going to put the rotate left instruction here. Rotate left instruction double word. The input will be QW0, the output will be QW0, and let's say we change it the bit changes or the bit shifting will be 2 bit. Okay, I delete the rotate right instruction, and I want the on status start from this bit. Okay, when start from that particular bit, the hexadecimal number will be 0001. Okay, so I press download. Okay, I press download. Just turn on the monitor. Okay, if you can observe this blue LED, the most right blue LED. See, so it very fast moving from right to left because we use the rotate left instruction. Okay, so it is very fast. It is quick, very quick. Okay, I think that's all for the demonstration. I hope that this video will help you to understand the rotate left and the rotate right instruction. Thank you very much.